Here's a list of the priors that Mplus offers. It's a screenshot actually from their user guide. And you can see they have the different types of parameters listed here, and then the distribution that's available and how that distribution is formed. So what its hyperparameters mean. So for example, if we have something that is normally distributed, what is the setting of that normal distribution as default within Mplus? And so they have a 0 for the mean and infinity. They don't really mean infinity. They mean 10 raised to the power of 10, but that would be the variance hyperparameter. So their default normal distribution is very flat, centered at 0, but a very flat distribution because it has a huge variance. We are going to use most of these different priors in the examples that I cover. I'll talk about the particular settings of priors for every example that we go through, and I will highlight when the default settings are not advised, which we will run into a few times. So now I'm going to shift over to Mplus and show you how this stuff can be implemented. But before we take a look at Mplus, I want to highlight a couple of readings that I think are relevant that I would recommend. There are 2 specific chapters that are in the Mplus user guide that I think are particularly helpful. They're going to have all of the information that we need for this section in order to modify our priors. So next I'm going to shift over. I will open up Mplus and we will look at an input file and see how exactly we can modify the priors that are produced. All right, so I've opened up Mplus and I've opened up our input file that we'll be working from. I have all of the relevant files here in this folder on my desktop. I have an input and output file. I've got a data file, and then I have this regressioninfo.dat, which is the MCMC chain information that I have staving out after I run the analysis. That way, if we wanted to, we could read it into R to create plots, as I showed you last time. So in this example, I'm going to use the exact same data that we had last time. We were looking at multiple regression, and we wanted to predict cynicism using 3 predictors. So we had biological sex, trust in other people, and faith in others. This part of the code is all identical to what we saw last time. I did not change any of the settings that we see here, except for these 2 sections. So this first section, the model, I'm actually conducting the same model, but I've written the code in a slightly different way. And that's so that I can easily show you exactly how this labeling system works in the code. And this is how we link priors to certain parameters. So we still have one outcome in the model, and that's cynicism. And we have 3 different predictors. We have sex, trust, and faith in other people. What I've done is just break this up into 3 different lines so we can clearly and easily see this labeling system. Having something in paren like this, reg 1, I could have written anything I wanted to here, but having this set up exactly after, directly after I've set up that parameter, so it's a regression coefficient governed by the word on, means that I have now labeled it this certain code, reg 1. So I have each of my regression coefficients labeled 1, 2, and 3, and I can now use those codes down here in this new section called model priors. And this is where we can overrideMplus's default priors that are implemented. So here I just put reg 1, 2, and 3. All of my regression coefficients, it makes sense for them to maintain being distributed normally. And we would have a mean and a variance hyperparameter listed for each. So what I've done is for each of these regression coefficients, I've said the mean of the distribution should be 0.25, 1.1, and 2.0 respectively. And then I set the variance of the distributions all at 0.5. Where did these numbers come from? I don't know. I made them up. That's okay. It's just for the point of the exercise. But the idea is that initially you'll just be playing with these and learning how it works. But when you go to implement this on your own, you will want to think very carefully about what these settings look like and have really specific reasons why your mean and variance were set the way they were. But here, let's just say that we had some reason that was important, and this is exactly what we wanted our priors to look like. Again, the rest of this looks the same as what we did before. I'm going to save out my MCMC data into this additional file in case I want to use that later. But we can go ahead and save and run this. It should be very fast to run. Yep. And what it will do initially is spit out all of the input so we can see. We have still, I think, a case with missing data. Then we have one group, 612 people. We have one DV, and that is cynicism. We have 3 IVs. Those are the 3 predictors: sex, trust, and faith in other people. This next part gives us information about the Bayesian estimator. So we used Bayes, and all of these settings are identical to the last lesson. We did not change these at all. These next parts of the output are identical to what I talked about before. We have the covariance coverage. We have univariate sample statistics. We're told everything terminated normally with estimation, which is great. We have information about model fit, which I cover in more detail in another lesson. And the results. So we now have results of an estimate of 0.3, 1.2, and 2.0. If we kind of put these side by side, we can actually see that there's been some influence of the prior. So they don't look that off from the prior distributions. And it's because I gave them pretty informative priors just to kind of play around with. So we get the results. These are results that tie in our theory through our prior that we've been overriding the default settings for within Mplus and using our own subjective information. Again, Tech 1 will number the parameters for us so we can see the internal numbering system that Mplus uses. We then see starting values, and then our priors are listed. And you can see here that we have all 5 parameters in the model have been listed. This is the intercept that's tied to the outcome. This is that residual variance. Those 2 were left as default settings, but the 3 in the middle, these are our 3 regression parameters. And we went through and specified our own prior, and they are listed here. And it gives information about the variance, hyperparameter, the mean, and then what that would convert to as a standard deviation for that. So the priors are exactly what we asked for. We then go into Tech 8, which is information about convergence, and we can track which parameter had the highest PSRF, just like we saw last time. So we scroll down here, we should get up to 50K. Next, we have iterations for, this is, I had it backwards. So here, iterations for computing PPP. This is a new part of the output that we haven't seen yet. So let's ignore this part just for a second and scroll down here. You know, it's far. So we have iterations for model estimation. So this is the part that shows you for the chain, which parameter is going to have the highest PSRF and how that's linked to convergence. And we can see that the PSRF is really tiny for all of these iterations, and it goes all the way up to 50,000. Now, this section that I kind of stumbled over a second ago has 50,000 iterations represented. This is a new section of output we haven't seen yet. We're going to put this into motion in one of our lessons later on. The PPPP is a particular type of index that I will teach you about that you can use to track how appropriate a prior setting is for a particular parameter. It's triggered in Mplus when you use a normal prior that has a reasonably small variance hyperparameter. And it's a certain type of prior that has a name, and I'll tell you all about it later. But when you use a override the default setting and use a subjective prior that has a small variance, that can sometimes trigger this PPPP part. If you didn't mean it to, it's fine. You can ignore it. And so for right now, this doesn't mean anything to us yet. And so we just kind of scroll by it, and that's fine. I will teach you about PPPP, and we will put this into action and actually use it as an important part that creates flexibility for us in the model. But when you have a subjective prior with a small variance hyperparameter, it will trigger this part of the output to be double long because it's computing it for something else as well. We will tackle that in a bit. All right, and then at the end, we get the information about the data file that it's saved out for us that we can read into R if we want to. And so that is the gist of how you go through and change a prior distribution in Mplus. It's pretty simple. You just have to know what type of prior you want to use, normal, inverse gamma, whatever it is, and what the hyperparameters mean so that you can go through and put meaningful numbers in those hyperparameter elements in the code. So otherwise, the output that you get looks very similar, and you would just then interpret the results in the context of the theory that you've now embedded through your subjective prior.